Point 5, repeated sampling and hypothesis testing. So when sample is repeated, the standard deviation will be sigma or divided by square root of n. So let's just do an example here. Also, the mu gonna be the same as the mu. The tires on a rental car fleet have lifetimes that are normally distributed with a mean life. This is the mu. So mu is that. And a standard deviation of 4,800 kilometers. Every week, a machine checks the tires on 10 randomly selecting cars. So basically, you're doing repeatedly 10 trial, right? This is the mean. The mean of your repeated sampling that you do is equivalent to the mu, the population. Sigma is equal to sigma of the population divided by square root of the n. N is 10 here. Sorry, it's you're doing every verb and then 10 randomly selected cars. What are the mean and standard deviation of these samples? Okay. 10 cars, each car has, 10 cars, each car has 4 tires, right? Totally 40 tires. You're checking 40 tires. That's why sigma is, you got it 4,800 divided by square root of 40. Now, we checking that we want to find, so, okay, we did mean and standard deviation here. How likely the machine to find sample mean of 62,500 kilometers or less? So 62,500 kilometers or less means X should be less than this. So 62,500 or less means this should be, 62,500 or less means this should be included, right? That's why you have to go a little bit higher. You have to go 63,500 maybe, and less than that. So make sure this is included in your data. 63,500. So I'm turning this one to the z-score. Z-score is the x minus mu x bar, sigma x bar. Mu x bar, we got it here, 64,000. And sigma x bar is 759. So z less than negative 1.98. You look at the table, negative 1.98, negative 1.98 is there. 0.0239. 0.0239, that would be the answer. So let me just erase this. Now, hypothesis testing. Okay, what is the hypothesis testing? Let's say you have any company making a statement and you want to see if this statement is right or wrong. For example, consider this scenario. A large candy manufacturer that produces a chocolate is saying that the chocolate weight on a label is 45 grams. A company spokesperson claims, so the mass normally distributed with a mean of 45 grams and a standard deviation of 2 grams. So, and they claim that this has a 45 gram. They purchase and weigh 30 bars. The mean mass is 44.5. Is this evidence enough to challenge the company's claim? So company is saying that as exactly is equal to 45. So the hypothesis, so we have a null hypothesis, a state null hypothesis. They wanted this challenge. The null hypothesis said that for chocolate bar, mu is equal to 45, okay? And the alternative hypothesis means reverse of that. Reverse of that is when we say no, it's not 45, it's less than 45. Okay. Now, step 3 that you need to take is establish the decision rules. Means how far, let's say we want to do this testing and how far is acceptable, the significant level, like 5% or 10%, right? So make sure you just choose your significance level. Step 4, conduct experiment for these 30 bars. So we conducted experiment and the experiment is 44.5, right? So we assuming the null hypothesis is true. When it's null hypothesis is true, means mu is equal to 45. So mean value, okay, here is mu is 45. This is your null hypothesis. We consider that to be true. You want to find the probability that is x is less than 45. This is my experiment. So convert this one to the z-score, 44.5 minus 45, which is mu divided by sigma. Sigma is a standard deviation, which is 2 divided by the square root of 30. So where we got that, it is have been given to you. Which is the standard deviation for chocolate bar weight is 2 grams. And you do this experiment. So when you do this probability, the probability is going to be 0.853, which is 8.5. 8.5 is bigger than your significance level. Okay, let's just explain the significance level and what we have. You do the experiments, right? We know this is the middle one is 45. The 45 is claimed. You do the experiments is 44. It is 44.5. We got this area to be 8.5%. My significance level is 5%. So this is more than 5%. So it means bigger it is better, right? If this is closer to your hypothesis, right? If we say 5%, this is my 5%, let's say. This is my 5%. 8.5% is bigger than 5%. It means this, what you got is even more, is better, is closer to the claimed value, which is 45. So therefore, there is not enough evidence to reject null hypothesis. If somehow you got the number less than 5%, you will say that you reject the null hypothesis and say you have enough evidence to reject the null hypothesis. Now here is drug effectiveness. A company, you tested new drug 250 pigs. So your N is 250. Historically, 20% of the pig will die when they get the flu. So your P is 0.2 or 20%. Of the 250 pigs treated with a new drug, 215 recovered. 215 recovered means how many of that die is 250 minus 250 is 30. 30 of them die. Sorry, 35 of them die, right? Make a hypothesis test drug effectiveness with significant level of alpha is 1%. So we can find mu is NP because we have a percentage with P20. NP is 50. So NP and NQ should be greater than 5, which is, we can test that, and this sigma is the square root of NPQ. My null hypothesis will be that the death will be 2 and 20%, as I said historically. And the alternative hypothesis will be saying that less than. less than this. Okay, now, if you do this, you wanna find the probability that is X less than 35. I want to test that, right? Obviously, P less than that. So we can convert this one into the z score P z less than 35, your X minus mu. Mu is 50 divided by 6.32. Okay, I'm just gonna put that in a calculator to see what is this value. Is negative 2.37. We go to the table here. We go to the table, negative 2.37. Negative 2. Sorry, this is negative 2.3 here. Now 7 is there. 0.0089. Okay. 0.0089. So here is approximately 1%, less than 1%. So this is the less than 1%. This is less than 1. There is enough evidence to reject the null hypothesis. So is this one, the probability is less than the significance that observed. The result hypothesis said that to accept H1, right? Drug operate to have some effect on the recovery of 1%. So just how 1% is very far. Less than 1% means the death that was here. You have this mu to be 50, right? Since this is 35 here, this area is less than 1%. Is 0.9%. Is much more further from 50 death, right? Therefore, we say that the drug has some effectiveness. Okay, to practice, you can do question number 4, 5, 6, 7, and 8.